Hello, dear and beloved science students. It's your favorite sixth grade science teacher, Mr. Heckenlively, coming to you on Wednesday, May 6th of the lockdown. Hope you guys are doing well. Hope you are treating each other well. And hopefully you are taking this time to learn some new skill that you have wanted to acquire. Okay, so what skills am I acquiring during the lockdown? I am figuring out new technology. So we're going to have our Google Meet for anybody who wants to come and say hello tomorrow. Period 5 will be from 8 to 8:20, and period 6 will be from 8:20 to 8:40. So hoping that I will see you there. Okay, so I'm going to go over a tale of two scorpions. And I have to say, I just really love science. This is such a great assignment. Now, let me tell you why. So, a tale of two scorpions. How do we think about that? And so I say we like to really sort of try to figure out what it all means. What is going on with nature? And I say it means don't mess with the guy who can hurt you. Okay? Don't mess with the guy who can hurt you. So let's kind of go over a bit of this assignment. So it says, animals have evolved many ways to defend themselves against predators. Many species use camouflage to avoid being seen. Others rely on speed to escape. Some species avoid capture by hiding in a safe place. Other animals use painful and venomous bites or stings to try to prevent attacks or to make being captured more difficult. Anyone who has been stung by a bee or wasp understands how stinging could be a great way to keep predators away. However, there's little research that documents if painful stings or bites deter predators. The grasshopper mouse lives at the base of the Santa Rita Mountains in Arizona. Scientists Ashley and Matt have been studying populations of this mouse for many years and wanted to know what the mouse ate. In the mountains, there are two scorpions that make a great food source for the mice. One of the scorpion species has the painful stings. The other species is slightly larger, but its sting is not painful. Ashley and Matt thought the use of a painful venomous sting helped the smaller species avoid most predator attacks. So, if you're looking to come up with a hypothesis, I would say that the hypothesis would be something like having a venomous sting will deter predators from eating that animal. Okay, so phrase it however you want, but that's just the general idea. So if you had the scientific question would be something like, does having a venomous sting prevent predators from attacking that animal? Your hypothesis stated as a prediction would be something like, animals that have a venomous sting, or I claim that animals that have a venomous sting will not be eaten as much by predators. So really, they came up with this ingenious experiment that they got 6 grasshopper mice from the wild. They trained them that when they tipped over a little cup, they would get some food snacks. So they trained them to do that, and then what they did was they gave them an option of cups that had both the smaller venomous scorpion and the larger non-venomous. Now I really like the picture that they have here. So you can see that there's the smaller venomous one and the larger non-venomous one. So there you have it. You have the happy scientist there. Okay, then you have got this data table, and it asks you to fill it out, and all you're doing is you're just counting it up. So let's say you're at the approved category and you see 5 out of 6, 5 out of 6. All you're doing is you're adding those numbers up. So let's see if I simply took, let's see, I'd go 6, 12, 18, 24, 29, 35, and we have 5, 10, 12, 16, 20, 22. So you'd get something like that. 22 out of 35. Then in order to get a percentage, all you're doing is you would, and you can just do this on a calculator, it would just be 22 divided by 35, okay? So something like that, okay? So just do that for all of them. You'll get all your numbers. It'll make sense. And remember, like if it's 0.6, that would be 60%. If it's 0.66, that's 66%, okay? So what data will you graph to answer the question? Would be the independent variable would be the type of scorpion. The dependent variable would be whether the scorpion was eaten first. They give you that graph of the data, and it really is pretty dramatic because what you see is the difference between how the mice will go after the venomous scorpion and whether they will, and the non-venomous one, and which one they'll choose to eat. So the mice may, initially look at both of them, but they really do not make the they do not make the effort to attack. So you can see as you get to the attack column, there's like nothing there. They do not attack, they do not consume the venomous ones. So really shows that the mice are pretty smart, they know what they're doing. So make a claim that answers a scientific question. It would be something like, painful scorpion stings will deter mice from eating them. What evidence was used to rate your claim? Reference specific parts of the tables or graph. So that's where you would want to have filled this out, gotten your numbers and percentages, and then use that in your answer. So if I'm asking for evidence, I'm always asking for numbers, okay? So keep your numbers in there. And then this is the last page, is just kind of your thinking. Explain your reasoning and why the evidence supports your claim. Connect the data back to what you learned about how prey uses defenses to deter predators. So you'd be saying something like, well, I thought that venomous stings would keep predators from eating prey. That seemed to be the case here because X, Y, and Z. Use numbers, okay. Did the data support Ashley and Matt's hypothesis? Yes. Use evidence to explain why or why not. If you feel the data was inconclusive, explain why. Again, numbers, numbers, numbers. When I ask for evidence, I want to hear numbers, okay? Your next steps as a scientist. Science is an ongoing process. What new questions should be investigated to build on Ashley and Matt's research? What future data should be collected to answer your question? So that's just kind of your opinion on whether you thought it was a good experiment, whether it fully answered the questions. I would think that at the very least, what you might want to say is something like, maybe we need to investigate other venomous species. Maybe this was just an anomaly, but the evidence looks pretty clear that venomous stings will deter predators from eating them. Okay, hope that's good for you. Hope you are being well, staying safe. I put another assignment into Google Classroom for Beetle Battle. So have fun with Beetle Battle. All right, thanks. Have a great day.